Suppose that instead of the integral of 1 over x squared minus 4 dx, suppose it was the integral of 1 over x squared plus 1 dx. What would you say? Arctangent. Everybody agreed? Hey, great. It's got that form to it. What if it said this? What if it said the integral of 1 over the square root of 1 minus x squared dx? You'd say arcsine, right? Yep. Arcsine of x plus c. Great. And would you agree? Would you agree that if it was, the integral of 1 over, say, 3x times the root of 9x squared minus 1 dx, although you may not know the answer right away off the top of your head, the fact is that you would maybe use arcsecant, correct? Well, 1 over x squared minus 4, that really doesn't, that doesn't have a form that we know, does it? What do we do about fractions that don't have a form that we really understand? Very good. Excellent work. Dylan is 100% correct. We put it in a form that we do understand. Okay? Put it in a form that we do understand. And the fact is that 1 over x squared minus 4 comes from some two fractions added together. Rebecca kind of gave this half-hearted laugh. I'm not sure what I should think about that in a response, but let's just think about this for a second here. Suppose that I had 3 over x minus 2 plus 2 over x minus 2, or plus 2. Could you add those together? Not right now. What do you have to find? Okay, well, we can do that, can't we? So we go x plus 2 or minus 2, and we go x minus 2, and we go x plus 2, and we go x plus 2. So we get 3x plus 6 plus 2x minus 4 all over x squared minus 4. Agreed? So 5x plus 2 over x squared minus 4, that was the same as 3 over x minus 2 plus 2 over x plus 2. So that thing came from those two. Everybody agreed? So that's what we're asking right now. Is the fraction that we currently see, what two fractions are added together to get that? That's a good guess, but it's not correct. Would everybody agree that it's something over x plus 2 plus something over x minus 2? Oh, you would like to have subtraction in the middle. Here's the answer why. B could be positive or negative. So if B is negative, then it ends up being subtraction. Okay. All right, well, let's just think of how you would solve for this. You would multiply both sides by a common denominator, correct? And so in this situation, you would multiply by x plus 2, or x plus 2. This side, x minus 2, x minus 2. And so here you get a times x plus 2. And here you get b times, x minus 2. And let's just think about this, everybody. This is where you got to use a little bit of logic. Are the denominators now the same? Yeah, we don't need to worry about the denominator at all, do we? Would everybody agree that this is the numerator? And in the end, the numerator is supposed to be equal to what? 1. Now, let's think a little bit more on this. a times x minus 2a plus b times x plus 2b is equal to, and here's where we got to get smart. Notice in my previous example that I put you up on the board, we ended up with a 5x plus 2 in the numerator, right? Well, how many x's do we have in this problem in the numerator? None. So we have 0 x's, and then what is our constant? So that means when you gather your coefficients together for the x's, they must add to what? 0. So therefore, a plus b is equal to 0. If you take ax plus bx, you get 0x, right? So that means that the coefficient for this x, a, and the coefficient for this x, b, a plus b must end up being 0. And then negative 2a and positive 2b, those must add up to be 1, correct? Negative 2a plus 2b is equal to 1. Oh, boy. Substitution, sure, or you could do elimination. I like elimination a lot more. I'm going to multiply the top one through by 2 to get 2a plus 2b is equal to 0. I'm going to add them together to get what? 4b is equal to 1. So b is a fourth. Hey, now they know that b is a fourth. Can I figure out a? What is a? Negative 1/4. Answer. It does matter. Yeah, very much so. Because a, or negative 1/4, goes over the x plus 2. B, so you put a over x minus 2? Is that how you set it up? Then you're fine. Okay. All right. Everybody see how we got these pieces? So I took the blue one and I multiplied through by 2. Give me the green one. Add them together. That's what we have. So what does that mean for us? That means this. The integral of 1 over x squared minus 4 dx is actually equal to a different integral. It's equal to an integral. I'm going to rewrite it. Instead of a, I'm going to have negative 1/4 over x plus 2 plus b, which is 1/4 over x minus 2 dx. So the question is, can we find that integral? Chris says yes. Riley says no. Arm wrestle. Let's go. Let's do it. Well, no big deal for us. We just start with this one. U is equal to x plus 2. So what is du? Just dx, right? Well, we don't have a dx, we have a negative 1/4. So negative 1/4 du is equal to negative 1/4 dx. So I go negative 1/4 integral du, and what remains? 1/u. What is the antiderivative of 1/u? Natural log. So you get negative 1/4 natural log of x plus 2. I just chose it. We're going to do x minus 2 for the next one. If x was negative 5, then that would produce a negative value, wouldn't it? Now, Tamara asked a good question. Why do we choose u to be x plus 2 as opposed to x minus 2? Well, I just chose x plus 2 for this part. Now I'm going to do plus this one right here. But can anybody just look at this and tell me what it's going to end up being? Now, that's an acceptable answer right there. Do you remember what we can do, though, instead of adding? What can we do to the... because it's negative? Right, so what you could do is, there's a number of ways you can write this, okay? So I'm just going to rewrite it one way for you right now. Does everybody agree it's 1/4 times the quantity natural log of x minus 2 minus the natural log of x plus 2 plus c? Everybody agreed? So since I have subtraction, I'm going to divide those two. So 1/4 natural log of x minus 2 over x plus 2 plus a constant. You know, the most common way for people to express the answer would be like that, I would say. But without a doubt, this is an option right here. What do you think? It is a long process. Yep. It goes by a couple names, integration by decomposition or integration by partial fractions. These are kind of the names that are utilized. We've got to 11:07. We can get the second example done, so that way on Monday, we just have 2. We're not going to do it. We're just going to skip it. I don't think I've ever done that to you before. That's what the AP exam is for. Okay. This does not have a form that we recognize. It does not have a form that we know. So what are we going to do? We're going to quit? Okay. Great question. What if it didn't factor on the bottom? Then you quit. Then you're just done. That's why integration is so challenging, and that's part of what makes up a lot of calculus too, is how do we work through integration of things that are super challenging. So these guys have seen integration by partial fractions as well this year, right? Let's give you a nice little introduction to help you out. Yep. So, all right, let's go. I'm going to say that this comes from some other integral, namely that the integral of 2x plus 3 over x squared minus 9 dx is equal to the integral of some a value over x plus 3 plus some b value over x minus 3 dx. I just have to figure out what a and b are. Braden's left-handed. So is Cole. All right. So, anybody remember how I set this up? We would multiply the top and bottom here by x minus 3, top and bottom here by x plus 3. So we have a times x minus 3 plus b times x plus 3 is equal to what? What does the numerator need to be equal to? 2x plus 3. Or in other words, ax minus 3a plus bx plus 3b is equal to 2x plus 3. Are you good here? Yeah. So I just distribute the a to each term, distribute the b to each term. So now I want to focus on the x's. So could somebody give me an equation that relates the x's? Good. And somebody else give me another equation. Good. Now, I'm a person in this situation, and you can handle it however you want. But without a doubt, I like to factor a 3 out of the bottom. So you're allowed to divide through or multiply through anything that you want. So this makes Rebecca uncomfortable. I'm sorry, Rebecca. But I have a plus b is 2. And on the bottom, if I divide through by 3, I get negative a plus b is equal to 1. Just like you can multiply through by whatever we want, you can divide through by whatever you want. Because dividing is just multiplying, right? By the reciprocal. I add them together and I get 2b equals 3. So b is 3/2. So how about a? 1/2. It's important to know where they came from. 3/2 or b goes right there, whereas 1/2 goes right there. Yeah. And I'm going to write this just a little bit differently this time. We're going to have 1/2 integral of 1 over x plus 3 dx. And I have then the integral of, 3/2 times 1 over x minus 3 dx. Everybody agree that these are the two integrals that we're going to be trying to determine? Yeah. Okay, I'll just go back and write it the other way. Because that's the way I like to do it. So I'll write it all out. We'll go 1/2 over x, what is it, x plus 3 plus 3/2 over x minus 3 dx. So I'll write it out like that so you can see how it matches before, but without a doubt, if I was a professor in college, I would never write it like that. And in my own work, I will never write it like that, okay? So I'll show you then how I move past that. I say I'm going to take the addition and I'm going to break it up into two integrals. So I'm going to factor the 1/2 out front. 1/2 times the integral of 1 over x plus 3 dx. Plus factor the 3/2 out. 3/2 integral 1 over x minus 3 dx. So it just went from that step to that step. Anybody know the antiderivative of 1 over x plus 3? Yep. So have we done that enough now to where you know that the integral of 1 over x plus 3 is just natural log of x plus 3? Now I want to caution you, if it was different, suppose it was the integral of 1 over 2x minus 5 dx. Well, it's not natural log of 2x minus 5. Because here's why. Watch, you got u is equal to 2x minus 5, right? Well, what's du? 2 dx. Well, you don't have a 2 dx. You have a 1 dx. So you have to be 1/2 du is equal to dx, right? So the difference is here is that if u is x plus 3, what's du? Just 1 dx. And if u is x minus 3, what's du? 1 dx. So when it just ends up as 1, it works out rather nicely. So sure enough, I get 1/2 natural log of x plus 3 plus 3/2 natural log of the absolute value of x minus 3 plus a constant. That's it. What do you think? Integration by partial fractions. I will give you your worksheet. We are going to work again on it on Monday.